Hello and welcome to video 9 of Module 4, the coefficient of determination. This video is going to be our last video in Module 4. So let's get started. All right, let's begin with a definition. The coefficient of determination, which is equal to r squared, tells us the proportion of variation that's explained by the least squares regression line. The closer r squared is to 1, the closer the predictions from the least squares regression line are to the actual data values on average. Okay, so that's a lot of words. What does this all mean, right? So there's a lot more detail than I'm going to be getting into here. So I'm just going to give us a big picture idea of what the coefficient of determination means. So let's take, for instance, income and experience, years of experience at a place of employment, right? So how long you're at a place is probably correlated to how much money you make there, let's say. So if I look at one employee and I look at their income, and I look at another employee and I look at their income, and they're different. And I want to know, okay, what percent of, like, how much of that difference do I understand based on their experience at the institution, at the place of employment? So if r squared, if the coefficient of determination is really close to 1, let's say it's 0.95, this would mean that 95% of the difference between their income, the money they make, is based off of the analysis I've done, which in this hypothetical situation is years of experience at the place of employment. So if r is really close to 1, then that's going to, if r squared is really close to 1, then that means that 95% of the difference in their income is based on their years of experience. And 5% of their income is based on some other variables that I didn't take into consideration. So some lurking or confounding variables. If r squared is not close to 1, if it's something like 0.02, right, that would be 2%. In this case, that would mean that 2% of the differences that I'm noticing between the income for these two employees is explained by their years of experience. And 98% of the differences that I'm seeing is explained by something else. So the coefficient of determination tells us like what proportion or what percent of the variation we're noticing is explained by the regression analysis that we've done. The closer r squared is to 1, the closer we're going to expect the points to be to that least squares regression line, because that's what's doing most of the explaining of the variation. And the closer r squared is to 0, the more spread out we're going to expect those points to be. But wait a minute. That kind of sounds like what r was supposed to be doing, right? R was what told us the strength of a correlation. So it's a subtle difference, but it's an important one. The correlation coefficient, which is r, tells us how close the data are to forming just a line. So are they close to a line? Great. R is going to be close to positive or negative 1. The coefficient of determination, which is r squared, tells us how close the data are to the least squares regression line in particular. It tells us how close the data are to this line that we've worked so hard to find. So the correlation coefficient is a broader summary value to just, are they close to a line or not? Whereas the coefficient of determination is more specifically, are they close to the least squares regression line or not? So let's do a couple of examples of working with the coefficient of determination. This first example is probably the most straightforward way we're going to see it. So Sergey compares the revenue generated by arcades, X, to the number of computer science doctorates, Y, for several years from 2000 to 2009. He finds an R value of 0.9848. What is the coefficient of determination? So the formula for coefficient of determination is just r squared. So that's all we have to do. We have to take our value from r which was 0.9848, and square it. Throw that into a calculator, and you're going to get this gorgeous number, 0.96983104. Ta-da! So the coefficient of determination is not a hard thing to find, but it's a lot like variance. Remember back when we talked about measures of dispersion and we had range, standard deviation, and variance? And variance is the one that a lot of students miss on a test, not because it's a hard thing to find, but because it's so easy we forget about it. That's the deal with the coefficient of determination. It's so easy we forget about it. So you want to make sure you have in your notes coefficient of determination r squared. The other thing that's confusing is that r is the correlation coefficient. So we now have two coefficients that are related to correlation. So we have to make sure we have them straight. R is the correlation coefficient. R squared is the coefficient of determination. Let's do one more example that's a little bit more challenging than this one. So throughout the Module 4 videos, we've been looking at data that Harriet collected about the displacement volume and gas mileage. So in a previous video, we found some summary values for this data, including an R value of negative 0.9060. In this example, we want to know what percent of the variation in displacement volume is explained by the least squares regression line. Round your answer to the nearest tenth of a percent. So, this problem doesn't directly tell us to find the coefficient of determination, right? Wrong, it does. It just calls it by what it is instead of by its name. Remember that the coefficient of determination tells us the percent of the variation in the least that's explained by the least squares regression line. So this phrase here is actually telling us we need to find the coefficient of determination. So we need to find r squared. Because our r value is a negative number, I need to make sure to use parentheses when I type it into a calculator. Otherwise, it's going to give me a negative number. And because r squared is a squared value, I can't get a negative number out of it. It's got to be between 0 and 1. So when I type this into my calculator, I get a nice long decimal, 0.820836. Now, if this problem had asked us what proportion of the variation, blah, 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 then I would leave my answer in decimal form. However, it asked us what percent instead of proportion. So because it's asking us what percent of the variation, that means we need to change this decimal into a percentage. You can do that by either moving the decimal point to the right 2 places or multiplying by 100. Either way, you'll get 82.0836%. The very last step of this problem is to round our answer to the nearest tenth of a percent. So the 8 in the hundredths place is going to cause the 0 in the tenths place to go up. So our final answer is 82.1%. What that means is that the gas mileage that we were investigating throughout this series of videos, 82% of the differences in the gas mileage for those vehicles is explained by our least squares regression line, which means there's 18% that's unexplained. It's unaccounted for in the data that we examined. So there are some other variables in the background that are influencing the mileage other than just the displacement volume. All right, that concludes this video on the coefficient of determination. And in fact, it concludes our Module 4 videos. The next video will begin with Module 5, which is going to explore probability. Thanks for watching, and have a fabulous day.